Section 7.7 talks about integration by parts. And what this does, it's undoing the product rule. If you take a derivative of u times v, let's go more official. If you take a derivative of u times v, that would be u prime times v plus u times v prime. And if I integrate both sides with respect to x, this would be simply u dot v, because the integral with respect to x of the derivative with respect to x, they undo each other. And here you would have the integral of v dot, I'm going to rearrange the order, plus the integral of u and if I move this to the left and this to the right, I'll get the integral of u dot v prime dx equals change of plans. Just move this to the left side. So I'll get on one side the integral of u dot v prime dx to equal u times v minus the integral of v times u prime dx. Now, do remember that v prime is dv dx. So when I say v prime dx, if I multiply this by dx both sides, those will cancel out, and this will be the integral of u dv equals u dot v, or u times v, minus the integral of v, and similarly this is du. And that's the shorthand for using integration by parts. I suggest you list that every time you're doing this until you get the hang of this. This is the deal. I'm taking an integral that I can't integrate. What this allows me to do, it allows me to take a derivative of one portion of that integral and integrate another. This I might not be able to integrate, but this I might. So, the idea is, what do you let u equal? You're going to let u equal something that would be beneficial for you to take a derivative of. Meaning, you should let u equal a quantity that when you take a derivative of, it disappears. For the most part, that works really well. So for example, I look at example 1, I see the integral of x times the sine. So I'm thinking, my choice of u would be, if I take a derivative of it, it'll disappear. I know how to take a derivative of an x, and I know how to take a derivative of a sine, but x times sine is very hard to do. Using a u sub by itself is not sufficient. It doesn't work. If I let u equal x, for example, du will be dx. This will become the integral of the sine of u du, and this, so all what I did, I changed the letters from x to u, which is useless. I still don't know how to integrate this. So, if I look at those two functions and I want to make my choice for u, I choose u to be whatever I can eliminate by taking enough derivatives. The most known that we know of are the polynomials. If you take a derivative of a polynomial, eventually it will disappear. The derivative of that, so every time you let u equal, you're going to take a derivative of that because you need it right there. And every time you let dv equal a quantity, you're going to integrate and get v. Every time. So the derivative of u is really the x. That piece is done. That's good. And now what? dv, unlike the u sub, dv should be whatever's left over. So the catch between u and dv, you need to choose the entire integrand, all of it. So whatever's left over must be my dv. And that you have no choice over. And you integrate because you want v. What do you take a derivative of to get sine? Negative cosine of x. Now, according to the formula, I let this be u, and I let this be dv. According to the formula, that's going to be u times v. That's going to be u times v minus the integral of v du. I suggest you memorize that. U times v is right there. U times v. X times negative cosine of x minus the integral of v, there is v, du. Du is dx. And do you notice what happened? I was able to eliminate the x out of the integral, and negative and a negative will give a positive, right? Now, what do you take a derivative of to get the cosine? The sine of x. And that would be my answer. And that's pretty much it. So, let's see if it works. If I take a derivative of this, I should get the integrand. If I take a derivative of all of this, if y equal negative x, the cosine of x, plus sine of x plus c. If I take a derivative, negative I leave out of it, the product rule. Derivative of the first times the second, plus the first times derivative of the second. Derivative of sine is the cosine. Derivative of a constant is 0. This is negative the cosine of x. Negative times a negative is a positive x, the sine of x, plus cosine of x. Those cancel out, and I'm left with x, the sine of x. And there it is. So when the question comes up, what do you take a derivative of to get x, the sine of x, x, the sine of x? You take a derivative of this mess. Looking at this again, I look at example B, and if I let u equal, can you eliminate by taking enough derivatives? Well, obviously x. Then dv is going to be the leftover. dv is going to be, again, it has to be the whole integrand. In a u sub, normally we let u equal a portion, and du will be the rest. That's not how it works here. So if I take a derivative of this, that's dx. And if I take, derivative, that's dx. And if I find v, which is integrate, what do you take a derivative of to get e to the x? E to the x. So according to my formula, this is going to be u times v minus the integral of v du. That's going to be u times v. U times v. So the product of those, that's x e to the x. Minus the integral of v du. And that would be x e to the x. And what do you take a derivative of to get e to the x? E to the x plus a constant. There it is. And you want to check, you can again. If you take a derivative of this, derivative of the first is a 1 times the second plus the first times derivative of the second. And derivative of negative e to the x is negative e to the x plus 0. Those cancel out, and you're left with x e to the x. You could always check your work if you wish. You don't have to, but if you have time, that would be wise to make sure that you did this correctly. Now, if I get to the next set of problems, sometimes, so there are really two types of problems. One type in which you take integration by part multiple times. You let u equal a portion and eventually it will disappear. And another part in which you can't eliminate any of the parts. by letting u equal a piece, it doesn't disappear. And that we'll talk about. For now, let's focus on the first case. So I could do integration by parts once. Here, when I glance at this, I say, wait a minute, that's x squared, which means most likely I have to use integration by parts twice. Well, let's see. If I let u equal x squared, again, what do you let u equal? You let u equal whatever you can eliminate by taking enough derivatives. A derivative of that will be 2x dx. And if you let dv be whatever is left over, the sine of 3x dx, then if you integrate, v will be negative the cosine of 3x divided by 3. So this is going to equal u times v, negative x squared over 3 the cosine of 3x, minus the integral of u times v, minus the integral of v du. I almost forgot it. v du. So if I multiply those, wouldn't that be a negative 2x over 3 the cosine of 3x dx? I still can't integrate that, but I'll drag the 2/3 up front. But I was dealing with x squared times a trig function. Now I have an x times a trig function. So I'm heading in the right direction. But still I can't figure out what that is, so I need another substitution. I do it again. I let u equal, and now I'm only applying that on this interval. I let u equal x, du is dx. And I let dv equal whatever's left over. And when I integrate, v would be, what do you take a derivative of to get cosine? The sine of 3x divided by 3. So far I have negative x squared over 3 the cosine of 3x. I don't touch that. The 2/3, I don't touch that. But whatever comes out of that integral is u times v minus the integral of v du. So a bit more space. And if I say that is negative x squared over 3 cosine of 3x plus 2 over 9x the sine of 3x. Now let's see what happens here. That's a negative 2 over 3 times 3 is a 9. And the last piece of the puzzle, what do you take a derivative of to get the sine of 3x? Negative the cosine of 3x. What do you do with that 3? Divided by 3. I could do this in 2 steps, because the 1/3 you're going to drag up front, and that 1/3 gets multiplied by 2 over 3 gives you 2 over 9. You could make that a plus. You could make that a 27 if you like, but that would be the final answer. So some of these problems we need to do integration by parts twice. Some we need to do integration by parts 3 times. If I look at this problem, the same deal. If I glance at this, say, wait a minute, well, I'm going to let u equal x squared. du is 2x dx. Which means dv is going to be whatever's left over, e to the 5x dx. And if I integrate, v would be e to the 5x. If you take a derivative, you multiply, and the derivative you divide. This is going to equal u times v, x squared e to the 5x over 5, minus the integral of v du. If you multiply those, that's 2 over 5 x e to the 5x dx. So now I'm going to apply integration by parts, but only on this piece. So whatever comes out of that, I'm going to multiply by negative 2/5. I'm going to let u equal x. du is dx. I'm going to let dv equal e to the 5x, and I integrate. So v is e to the 5x over 5. This is going to give me u times v minus the integral of v du. So the 1/5 I'm going to take up front. This is going to equal x squared e to the 5x over 5 minus 2 over, or even better, I'll do it in 2 steps, unlike the previous problem, in case you didn't see that. 2/5 I leave alone. This parentheses is x e to the 5x over 5 minus 1/5. And what's this integral? Isn't that e to the 5x divided by 5? So my final answer is x squared e to the 5x over 5 minus 2x e to the 5x over 5 squared, which is 25, minus 2 over 5 times 5 times 5 is 125 e to the 5x plus c.